Hi. So as promised, I'm not going to give you a lot of theory. We're not going to spend a lot of time chatting about the ideas of computing or of interpreters or of compilers. We're going to jump right in and start coding because I think that's what you're here for. And one of the stumbling blocks to doing that traditionally is that you have to install your programming language or a programming environment on your computer. And we have to figure out whether you're using a Mac or a PC or a TRS-80 Model 1 or what it is you're using and how to get everything installed so that it's working, and then you run into a bunch of issues with that. We're not going to do that. We're going to be instead be using what is called Google Colab. Google has set up a Python interpreter, and an environment for you to use for free on its servers. And that way we don't have to worry about your computer, at least not for now. If you continue down this path, towards the end here, we'll talk about some various other ways you might be able to install Python, the different kinds of ways you could use it. But for now, I want to jump in and just use it. So what I'm going to do is go to colab.research.google.com. That's colab.research.google.com. And you'll see something like this, at least if you're logged into your Google account. You have a Google account most likely if you've used Gmail before, or if you have one through your university or something like that. If not, you can sign up for one for free. It's not a big deal. But you do need to be signed into Google because you can store things in your Google Drive. We'll talk about other ways you can store them later, but in your Google Drive for now using Colab. So if you go there, you'll see something like this. And I would say one thing you could do is start with Welcome to Collaboratory. You might actually see that first. I would say you should start with a new notebook and just kind of follow along, at least at these initial stages. I'm going to share the notebook I'll work with, which is this one. And you can kind of use that one if you want to see what I've done differently. But at least at the initial stages, I would just say start with a new notebook and follow along so you're playing along with us directly. So this is what's called a Google Colab notebook. It's actually based on a very popular way of interacting with Python for people in the scientific community called Jupyter Notebooks. And Jupyter notebooks don't just run on this. You can save these. You'll see, well, it's a little bit off the top here, but you'll see that this has a .ipynb extension to it. And what that means is you can actually load this in Jupyter Notebooks somewhere other than Google if you wanted to. But as I said, this is actually running on a Google server sitting out there on a virtual machine, and we get to use it for free as long as we don't get going on anything too crazy. It might be a little slow depending on what we're asking it to do, but it's meant as a way for you to learn Python, so it's ideal for us. There are two things you can put in your notebook. You can put text, as I have done here, by adding plus text, or you can run little snippets of code right in the notebook itself. So I'll do the first thing we're going to do is use Google's multi-billion-dollar infrastructure to do basic math, to use it as a calculator. So I can do something like 5 plus 5. And this is not actually a statement so much as it is what we might call an expression. So what is 5 plus 5? And if we hit this little thing here, it's going to think for a long time because it's not quite sure why we're asking that. That's not why. And it's going to come up with an answer of 10. So let's just note this with text that below we're going to be doing addition. One of the nice things about being able to add in text here is that it lets us know what we're doing. When you're doing work in social science, you probably are keeping a notebook anyway, but this lets you mix up your code with your notebook. So it's a good thing for other people to see what you've done, for sure. But honestly, for me, and this is not just because I'm old, but in general, it reminds me of what I was thinking when I was doing this and what kinds of steps I took to figure out how to make something work. So I'm going to try a little bit of subtraction. You might guess what we might do for a subtraction, right? The code would be 5 minus 5. And we'll go ahead and do, rather than doing separate things, we'll go ahead and do subtraction, multiplication, and division. Oops, we'll try to be able to type with people looking, which is never fun, especially with a brand new keyboard. So 5 minus 5 we know is going to give us 0. We can go ahead and do a 5, make sure this doesn't go off the bottom of the screen for you, 5 If you've used a computer at all in the last 20 years, you know that the star key or asterisk is for multiplication, is 25, and we can do one more snippet of code here and do 5 divided by 5, and we'll get 1. I may be testing some of your math skills here, hopefully not. 5 divided by 2 is going to get us 2.5, obviously. I should kind of note that there are some other ways to do 5 this isn't just a typo, but if I do 5 with 2 of those divided, it's going to give me kind of when you were a kid and you couldn't do the 0.5 part, you would do 5 divided by 2 is 2 with a remainder of 1, right? I'm mentioning this. You really don't need to know it for now. This is called the floor operation. It basically does the division, but leaves off the remainder. You can get what your remainder would be using what's called the modulus expression, which is the percentage sign. I'm mentioning these offhandedly. These are things you eventually will use, most likely if you've done any programming, but it's not something you have to have kind of at your beck and call. You can always look it up if you have to. There's limited approaches to why you would actually need to get your remainders right. You probably will need to use you're more likely to use something like this, which is 5 squared. That is 5 raised to the second power. So this is for exponents. I'll mention that we should, well, let's do this first. We'll put that in there so we can use it in a second. But what is 2, let's do it the other way. What is 3 plus 2 times 4? So what's 3 plus 2 times 4? And do it in your head. Now this is a very easy version of what you get on Facebook if you're old enough to be on Facebook every once in a while. It's an exercise in the order of operations. So in this case, it knows that you're supposed to do the times first. So it gets us 2 times 4, which is 8, plus 3 is 11, instead of doing what you might have mistakenly expected for it to do, which is 3 plus 2, which is 5 times 4. But if I want to do that, I can just put parentheses around it, and it will do it the way that you would expect it to do if you were doing regular math. So basic order of operations. Here I'm going to briefly indicate that there's a way of testing which numbers are more or less than one another. So let's do a quick, I don't want to lose you there. Is 5 more than 2? Hopefully you know the answer to this. It's true. 5 is more than 2. Is 5 less than 2? Nope, that's wrong. Here we're going to break it. Is 5 equal to 2? This is a common error for people programming in just about any language. Some languages let you do this, but mostly they don't. The equal sign does not mean equals. This is a pain in the butt. Now, I will note that this is good that we did this early on, because the way you learn is by getting these errors. Errors are an essential part of learning to program and of programming, and they end up being a lot of what you do over time. So there are 2 major categories of errors. One of them is the more difficult one to deal with, and that's when the program is doing something, but not what you intended it to do. So those are a little trickier to debug because you have to figure out why it's doing what you didn't expect it to do. This one's actually the easier of them, and this is a basic syntax error. As it says right here, it's a syntax error. Sometimes it actually tells you where the syntax error is, which is useful if you have a big program. Here we only have 1 line of code, so it says that's where our error is. It says you can't assign to a literal. And that's actually not very helpful as an explanation. What I could do is I could do a quick search of this particular error. I could go and look for can't assign Go and Google can't assign to literal and maybe look for it with Python attached. There's a little key here that says search Stack Overflow. I doubt something this simple is going to be in Stack Overflow. Stack Overflow is a question and answer site that actually does answer a lot of your error type questions. Here I'll just give it to you, which is that this is not actually an equals sign. So the less than sign is to test less than or more than. The more than sign is to test more than. But this equals sign is actually an assignment. And what it says is put this into this box. We're going to get to that in a second. If we want to know test if two things are equals, we actually have to use this. So this is the first time we get into something that's not obvious and seems a little tricky, but this is a pretty common error to forget that if you're testing for whether this is equal to this, you have to use two equal signs, not just one. And here we'll get false because shockingly 5 is not equal to 2, but 5 is equal to 5. And 5 is equal to 2 plus, oops, make sure that I'm hitting the plus key, plus 3. And that's still going to get us true. So this is, we're going to do some comparisons. All right. Finally, and this is going to be really important later on because a lot of what you do with the computer is to check whether something is or is not something else. So I think for now we can kind of just say that we've gone through using this as a calculator. The one piece we haven't used yet is storing some of the answers we have so we can remember them for later. And that's what we're going to get into in the next video.